Hello everybody, today I'm going to discuss about radiation cycle in the universe. Like I've said before, the universe, it seems to me, it is a sphere, one giant large sphere. Now, all the stars in this universe shoot out light in all directions. Now the question is, if there is a limit for this universe, after some time, after enough millions of years, the photons of every star, let's say from this star over here, moving in all directions, eventually they hit the wall. Now what happens? If there is a wall everywhere, what happens with all this large quantity of energy, of light, hitting the wall? Now we know from the physical laws that we have that somehow mass and radiation cannot just disappear. Somehow the energy we have in the universe is constant. But the question remains, if I have photons hitting this wall, what's happened with them? Well, it seems to me there is some sort of cycle with this photon in the universe, pretty much like the water cycle in nature, but a little more complicated than that. So we have to see how this works exactly. Well, first we have a star which ignites, and this star shoots out light in all directions. After some time, even that we are in a curved universe, these photons follow a curved trajectory. They move into the universe in all directions, and some of these directions eventually are heading here. So after some millions of years, we have a problem. What happens with photons once they hit the wall here? Now, physical laws that we have already, they are valid, and I'm not looking for other new physical laws which will somehow cancel that or complete that. Let's explain based on what we know already. My understanding of this wall is this somehow solid like not mass that we have. Like I've said, mass, you know from my previous presentation, a sphere of mass is in fact collapsed radiation. Inside is just radiation. So mass is just an illusion. We have a surface here, a reverse sphere all around it, and that is why we have a surface. But in fact, there is nothing solid in this universe. But this wall is something else. This wall is beyond me. This wall can withstand the initial big blast of the universe, the initial Big Bang. So, the question is, if I have a photon hitting this wall, what happens? Well, there are several options here. Once the heat and the energy is transferred by the wall outside the universe. The wall has a limit here, and it's transferred outside. Now that causes a problem, because we would lose mass and energy with time. There will be eventually less and less energy in the universe, no more stars, just blackness. And we don't see that happening. Somehow we know that inside everything is constant and there is no exchange with the outside. Which means this hypothesis is false. I don't buy it. What other things could happen? Well, photon hitting here would just stop and increase the temperature of this wall. So with time, the temperature would go up. So somehow the wall absorbs the radiation, but without it transferring somewhere outside. It just remains there. Now, from cosmological background radiation, what I understand is somehow into the universe, the temperature is very low. It used to be higher in the past, but now it's very low. It's very, very low. So if this would just overheat itself with time, we should see a wall everywhere around the universe increasing temperature inside the universe. It will just be some sort of an oven. And temperature will go up. But you don't see that. We really don't see that happening. The temperature of this wall, not only that remains constant, but it's basically going to the limit, the lowest limit. So this kind of hypothesis also false. Now there is another hypothesis. in case of light hitting this wall, maybe it reacts like a mirror and it shoots back everything. The entire quantity of light, of radiation, is being shot back. But when we look into the universe, we don't see that mirror. We don't see anything, it's just pure blackness. If that would be the case, we should see some sort of strange mirror with our telescopes, but you don't see it. That causes a problem with, we have to cancel this theory also. But in the absence of these three theories, where does these photons go? They cannot just disappear, or at least so we think. Now, if something disappears in this universe, it means that we don't know exactly what's happening with mass. But think about the preservation of mass. We know that we have a process, let's say this process, and I entered in this process with 100 units. 100 units of energy of whatever kind you want. And if I see with my measurements outside 70 here, I have to question, where are those 30? What happened? And someone might say, okay, they are here. They could be there here, or there are, let's say, 20 here, and 10 outside, but we don't have the capacity to measure them. So although we cannot measure everything, our laws tell us that basically on the principle, what goes around comes around, and this wall being impenetrable, energy remains inside. So, if the photons do not go out and do not come back so we can see them, they must be disappearing here in a strange manner, but they must be appearing somewhere else. Where could they appear? Think about it. I have a star, let's say this one, which is the sun. Now, the mass of the sun is constant, although it loses light and heat in all directions all the time. I have to question, if I have an object losing its energy that fast, shouldn't this object be smaller? Should it somehow reduce its size? Why this doesn't happen, at least not that fast? How come I have a star lasting for billions of years? In the universe is very cold, and this star is very, very hot. I think it should last only for 1 year or 2. I'm saying a random time period. But this lasts for billions of years. I find this very strange, nearly impossible. My understanding is that the photons hitting this wall, they appear in center of stars by a manner which is beyond me. The time between this point and center of the stars is 0. They disappear here and they appear in center of stars, refueling them for many billions of years. In such a way, it is closed cycle. Now this explains why the mass of stars is constant. If I lose energy from a star but the mass remains constant, once again I have to say, if I'm losing things, who's supplying me? How come I remain constant? My understanding is that whatever hits the wall appears back into the universe. And the only place where things may appear back but you don't see it, it must be in some center of stars. And there is another stranger phenomenon which happens into the universe where we can see it better. Every once in a while, in some galaxies, we have jets. Now these jets are very difficult to explain. Many scientists say there is a star here coming very close to the black hole. This is a black hole over here. And the star starts to lose its mass, falling into the black hole. And there is a limit. Part of the energy goes inside, but the rest of the energy is being shot out. I do not buy this theory, and I have tried to explain this before. There are no black holes into the universe. That's just impossible. The black hole cannot exist because it's impossible to have a constant radius. It is that the black holes are infinitesimally small. They have a very, very small radius and a very small duration of life. They appear and disappear in an instant in such a way it doesn't make sense to talk about them, or the black hole has a maximum radius. Which is the maximum radius in the universe? It's the universe itself. So if you want, the only black hole, the only dark sphere that we have, it's the universe itself. It's the only one. But the question is, what's inside the center of galaxies? Something strange is going on there. If we see no jets, we may assume there is nothing there. But when there are jets, what's happening? My understanding is that the photons which hit this wall appears under the form of mass in the center of galaxies, and they distributed mass into the universe. This is important. In the absence of this phenomenon, the universe would get just too concentrated, too fast. It eventually would have one cluster, let's say this one, gathering so much power, so much gravity, it would just break these filaments. It would just drag everything with it and drag the other galaxies near. And eventually, after billions of years, we would have one giant galaxy in the middle and nothing here. But the universe is very old, after my opinion, and we don't see that happening. I think we should see that. But can you show me one broken filament? We don't see that happening. How can that be possible? Well, my understanding is that whoever is somehow the administrator of the universe is taking care of these jets to be shot out into the universe exactly the right moment, in such a way later on clouds are being formed, stars are being born, and these stars are gathering into new galaxies in such a way, if there is too much gravity here, galaxies are being formed in these clusters around it, dragging this galaxy back. So if you want, it's a very strange cosmic dance. If you are a galaxy on a filament, what will happen with you after billions of years? You would just go to the left or to the right, and you would be this cosmic dance forever and ever. If you would be a galaxy in the cluster, you would just spin around the center of the galaxy, of the cluster, forever and ever. But a galaxy here, if you just move to the left and to the right. Why is this important? In the absence of the jets, like I've said already, things would just get too concentrated. If one cluster would just gather and eat all the other clusters, we'd have less things into the universe. But in this case, we have more things, but it's a dynamic equilibrium. And this brings me to the conclusion that whatever have here in the center of the galaxies are pretty much like white holes. I am not an expert in black holes or white holes, but I think it is like this. An event horizon around this singularity is needed because conditions here are catastrophically. Think about it. The last time when we have had creation of mass was inside the moment of the Big Bang, and that devastated the universe. But in this case, if we bring back such a strange phenomenon, it would just create a lot of waves, a lot of strange things, disturbing all the surrounding stars. And eventually, if there is a galaxy here, a very large galaxy, all the stars may be affected and all the planets. I'm not saying such a small singularity would just disturb the entire universe, but there are many of these kinds. A protection is needed. And this protection is the event horizon. In this case, nothing can fall in. It is impossible to have a star fueling this protection wall. This force field is protecting variations of any kind of strange phenomenon would this singularity generate in such a way these waves, when they hit this force field, they do not go out disturbing the galaxy. In this case, if I have mass hitting this wall or radiation, it will never penetrate it. Somehow this resembles much like a white hole, a reverse black hole if you want. But still, this we have to see exactly how this works. The conclusion is somehow simple. Because we have a wall everywhere around the universe, photons hitting this wall must go somewhere, and they go in center of stars and in center of galaxies under the form of jets. And this way, the conservation of mass into the universe, it is preserved. This is a very complicated phenomenon, and if water cycle in nature is somehow random, This phenomenon is a little more complex. How come the universe does this automatically? It's difficult to explain and difficult to say. How come these photons disappear here and they appear in the center of stars without us seeing them being transported there? Once again, is beyond this point. What I speak is what I see, and I understand the universe works in this manner, and this is what's happening with light and radiation cycling in the universe. This is what I wanted to present, and I think I am close to reality. If you think that this is somehow different, tell me so we can improve this theory. Thank you for watching.